So today's Wednesday, August 25th. And my son Nick learned how to surf. He finally got up on the wake surfing board. It's pretty crazy. My friend's got a wake surfing board. This was like a while ago. This was at he biffs it there. This was at Oroville, Lake Oroville. And then so today we will do introduction again, just some kind of answering some of the questions that you'd had already. And then, yeah, and then, hey, right now, do you see my chat when I pull up the chat from the class? No, good. Okay, it's on my screen, but it's not yours. I always wonder about that. Okay, past peer Morgan Fenig update. So Morgan is he has his past peer sessions again, same, okay, like I said before, Monday, Wednesday, 9 to noon, which is kind of weird because I want you guys all to come to this live lecture if you can. Well, how many do we have now? We've got a pretty good amount right now. I don't know how many it is. I have to stop sharing my screen to see it, I think, but that's okay. Oh, we have 20 right now. So I want more than 20 to come to the live lectures. Hopefully we have more straggle in. So I feel like if you can, it really helps. So, but if you're not at my lecture, I guess you could still be at Morgan's session. Did anyone go to Morgan's session today from 9 till now, till lecture started?
Yes. Okay,
cool. Good, so it worked. The Zoom link, when you went into the Zoom link, was it through Canvas?
Right, the link on Canvas, sir?
Yeah, this one right here. Yeah, you click on that and then it just bring you like kind of to a receptionist at the library, and you say you want to go to Morgan's session and it brings you there.
Right, yes, sir.
Perfect. Okay, yeah. So I've added Morgan's link into Canvas, Morgan's past peers. And then I also linked in Canvas, Morgan made up a Discord, and I think it's actually the Discord from last year. So it might be this, I think it's the same one. Is Morgan able to be here? Oh, he's still in his past peer room. He's probably not here. So yeah, the Discord is there if you want to check that out. I forget, somebody set this up last year. So if you want to go there, I think the Discord is better than the discussion feature that's a part of Canvas because it's easier to post pictures and things, I think. All right, so now let's check. Oh, I didn't animate that. That's okay. Let's see what we need to do. So that was one of the earlier questions. So I have the organic chem step-by-step. We already went through a little bit. I'll show you it again. So each week you just kind of come down and see your links to the lectures and things if you haven't been able to watch it live. And then office hours. And in the office hours, let me show you how this works too. I'd like more of you to come to office hours too. I have an office hour tomorrow. So if you go to like Tuesday's office hour from yesterday, you'll see the Jamboard for it. And Santos was in there with me. And so I made up some problems for him. And so here's Santos who's working on this. And I made up another one, hoping other people would come because I can just copy and paste it to a new Jamboard. And then if they can work it out. But if you want, there's more practice for you. And then this one got funky. Oh, I delete that one. And now we did I made up another problem for him. He was wondering about symmetry equivalence. We're going to get into that with NMR soon. So you can see it's great to come to office hour because I can make up a problem and then paste it on all these Jamboards. I can make up to 20 of them. And then I can even make a second Jamboard if needed. So I can have 20 of you in the office hour, and you all be working on the problems, and I just go through and I point out the little error here and there, and it really makes a difference. Helps you out a lot. Yeah, Annalise is mentioning the Discord servers. I can definitely see students cheating on an online exam on the Discord server, but so for us, we're going to do our exams in person in lab, so you won't have electronics out, so it won't be an issue. So that was the office hour, right? And then the assignments are down here, like I said. Just check here for due dates. And then I'll also remind you again in the lecture outlines what you need to do for the next lab period kind of thing. Okay, so I got that, and then the schedule. Let's check the schedule out again. So the schedule for tomorrow, we'll start experiment A, NMR, and IR. And so this is the link to the spectroscopy introduction, the one that you're going to, oh wait. I think maybe I should move that actually. I want you to start with IR. I made this schedule up and then I changed my mind. I think an IR is a better thing to start with. So let's do this. Oh, yeah, there we go. So how to use your IR spectrometer? You do that. You do for the pre-lab. You do the first couple questions. Actually, I should paste it that way, shouldn't I? I'll come back to that. And then so that's today and tomorrow. You have pre-lab and a bond line structure quiz, and then on Tuesday of next week, the second week of class, we'll do a locker check-in, and then you'll have a pre-lab for the spectroscopy intro two. Actually, do I have that? I try to give you assignments in multiple places, but I sometimes forget to put them in all the places. Sorry. Let me find this really quick. Lecture outline. This is the one. I think I put it in this lecture outline, didn't I? Ah, I didn't put it out yet. Just do the same thing. Oh, come on. I don't know what's going on. All right, I'll just type it in now. Okay, so I apologize. Start of the semester. Got a lot of stuff to set up. Pre-lab. Do answer at least. I think I had, it's weird, I wrote this somewhere. I think I had it up to like question 10.
I'm pretty sure it was 11.
Was it 11? Okay, you've seen it too, huh? Okay, good. Yeah, because this is when the questions are.
Dr. Springfield,
Yeah.
Goggles in lab.
Yeah. Get yourself some goggles by next week. Thank you for pointing that out.
So the
Okay.
pre-lab is like due for today. When is the whole thing due? The how to use the IR spectrometer like worksheet.
Good question. Yeah, it's not due for a little bit. I'll show you. Okay, I got that one in there. Oh, that's so weird. Sorry. Okay, so this is due Monday, Tuesday, week 2. I'll write down the date later. Okay. And I'll link it then too. All right, so oh, come on now. All right, so the due dates, good question. We can see that on Canvas. So if you come into Canvas and you go to, I'll start from the home page here. You go to assignments, there's assignments on the left here. So you can see when stuff is due. So the high risk waiver due by the 27th, how to use the IR spectrometer due by the 7th. The September 7th is when this one's due. And I'll go ahead and show you a little more about it. When you click on it, I have the link to the document, it's the same link you have in other areas. And you could turn it in as a PDF where you upload the file here, or you can turn in a paper copy in lab. And I'll tell you more about the due dates. I didn't talk about this last time, but I give you some leeway on due dates. So if you go to our due dates link here, if I click on that, you'll see I have this file where everything's due dates are listed. Oh, I have the pre-lab listed here. That's right. I said question 10. Huh? Okay, not 11. I knew I put it somewhere. I try to put stuff in multiple places so it all makes sense for you don't. Yeah. But if you your question was, I think it was Sam, you asked about the due dates. So this is where you want to look for due dates, this Google slide, or Google Sheet. And I put it in order of when it's due. So the pre-lab is the thing that's due most recently, today and tomorrow. Oh wait, that's the wrong due date. The 25th, 26th. Okay. And then the high risk waiver due by Friday. And now the other pre-lab is due. That's the dates, the 30th, 31st. Yeah, Monday, Tuesday next week. And this pre-lab is due the 12th, 1st, 2nd of September. So you just go down, see all your due dates. And whenever for most things that I have a due date, except for like pre-labs and certain things and quizzes, I'll give you a due date for, like, say, for example, the how to use our IR spectrometer, the completed all the questions answered. That's due on September 7th. But if you turn it in 4 days late, you're okay. I won't take any points off. So you can turn it in by the 11th without losing any points. And then if you turn it in though, after 4 days late, between 5 and 7 days late, you can only get like 50%. And then after that, you can't get any points. So this is a nice area to guide. And I should have the due dates linked in here, but it is linked via the Chem step by step. You can get there, due dates, boom, you got it again. All right. Good questions. Wait, I didn't have this guy. I have that linked. Animation. Okay, so now moving on to the next slide. There's student tech support out there available to help you. So I mentioned this last lecture, but I figure I'll mention it again. So for instance, like in lab for the beginning of this semester, for actually most of the semester, it would be really helpful if you had a tablet or a laptop, but a cell phone will work, but having a bigger screen might be helpful. So if you want to request one, you could try looking into requesting one. And come to lab this Wednesday or Thursday with the green pass, as always, the Sierra app where you scan to make sure you're not COVID contagious. And then the pre-lab for the IR spectrometer, getting through first couple questions. And then the bond line drawing skills, you'll do the quiz for the bond line structures from the bond line structures we talked about. Computing device with internet. So a laptop or tablet or cell phone. I think laptop and tablet are the best options if you have it. And apparently, do you guys know the apparently kid? I love the apparently kid. It's kind of old, but it's funny. So the apparently kid, apparently you can watch lecture videos just as it completes by downloading it from Zoom. I didn't know this. I know I download the lecture videos from Zoom, but I didn't know you guys could, but a couple of students told me in lab. I'm like, oh, so if you missed a live lecture and you wanted to watch it right away, you can get it quicker from Zoom than later. I actually post it on YouTube. And the Zoom one has the auto-generated text, but the YouTube video will auto-generate text as well. and you can fast forward through the break because the Zoom will still have that break. When I put it, what I do is I edit it. I download the Zoom video, I put it into iMovie, and I cut out the break and maybe the beginning part while I'm fumbling through something like today, maybe. And then I make it a little shorter, and then I put it on YouTube. And the YouTube, most of you probably already know, you can like speed up the video if you want, make it 1.5 times as fast or double fast. You know, if it doesn't drive you crazy, get through the lecture quicker, and you can pause. I think you can, I don't know, can you do the same thing on Zoom? Does anybody know if you watch it, the raw Zoom video?
Yeah, but I think the only options are 1.5 and double speed.
Okay, I think that's,
YouTube has more options.
all right, cool, thanks. But I'm gonna still always make I thought about it for a second. I was like, oh, it takes me time to edit, put it on YouTube. Maybe I'll just only get the Zoom videos. But after a while, the Zoom website says, oh, you're using up too much space. You gotta delete these videos. So I'm like, no, I'll just put them on YouTube. All right, I'll continue to YouTube because of that. Yep. And I believe it's best to watch the lectures live. So thanks for coming. And those of you who are watching this in the future, try to come to live ones if you can. All right, so now SOTW, what's that? Student of the week. So I'll try to do student of the week each week. I usually forget. I get busy and don't do it some weeks. But our first student of the week is kind of it is a student at Sierra College, but that's giving it away a little bit. It's a Golden Eagle. It's a high school grad of Deloro High School and a chemistry major. Will transfer to Berkeley. You know, I think that's still true. Not sure of a career yet, maybe teaching. Ran cross country and track in high school. Could jump about 6 feet. That's pretty awesome. Was a coach / jumper while in high school. So it was like a coach athlete. An Eagle Scout. Made a native plant garden used by Placer Nature Center that is used for Maidu Indian plant education. And did a bioresearch trip in Yucatan rainforest, which resulted in convincing the Mexican government to halt construction of a freeway. It's pretty cool, huh? And the student of the week is, does anybody know from those hints? Morgan Fenig. This is Morgan. So it's a student, but not currently enrolled in our class. Morgan was enrolled in OrChem last year, but he's our past peer this year. So this is Morgan somewhere in Europe. Okay, any questions about that intro stuff? Any more questions? All right. Okay, so let's get going. I want to do a quick review of the bond line structure stuff, just to kind of warm us up. I'm not doing the whole thing. I'm just doing one slide of it. And reminder again, that's the quiz today and tomorrow in lab. So here's our quick review of it. Bond line structure mastering. So let's say the number of hydrogens here. So this is from that steroid used to treat COVID. Boom, how many hydrogens? Oh, and I was thinking about this. I like when we're in person for a lecture on these things. The whole class can kind of speak out loud to say what the answer is. But on Zoom, most people are, and I'm included in that, usually don't have your video on, which is completely fine, but have your video on if you're comfortable. Either way, on or off. And then most people don't want to talk out loud, which I get to, but we have the chat. So maybe everybody go to the chat and type in for this box. How many hydrogens should we see here for this wedged out carbon? All right, I'm seeing a lot of threes. Looks like 3 is the answer, and it is, yep, 3 hydrogens there, because that it's called a methyl. It has 1 bond to a carbon and then 3 to other hydrogens, so no charge. What about this carbon here? This is called a carbonyl carbon. How many hydrogens? Yes, I've seen a bunch of zeros, good. Okay, and now what about this one here, this bend here? It's got 2 bonds to other, it's got a bond to an oxygen and a bond to another carbon, so it would have 2 hydrogens, perfect. And then here, how many hydrogens? Seeing a bunch of zeros, good. Got it, because it's got one bond to oxygen, one to carbon, one to carbon, one, 4 bonds total, it's done. This one over here, this dashed carbon. Again, it's like the wedged one. It's got 1 bond back to a carbon, so it needs 3 hydrogens. This one here, the bend again. All right, 2, you're getting it, good. So far, the text, the messaging app and Zoom has been 100% accurate. This one here, how many hydrogens for this one? Oh, I jinxed you. It's got 1 hydrogen because it's shown. It's kind of a trick question. Normally you don't show hydrogens on carbons in bond line structures, but for this one, we show it to demonstrate the stereochem of that carbon, which we'll talk more about stereochem later. So that was kind of a trick one. John in for stereochem, explain later, yeah. All right, what about this one? How many hydrogens for that? Okay, good. I didn't get fooled that time. There's a hydrogen there shown for stereochem. Here, this bend. 2, good. This one here. I see a lot of zeros and a 1. This one's 0 actually. So the double bond counts 2 bonds this carbon. So it's got 1, 2, 3, 4 bonds already. No hydrogens needed. This one. Okay, and in the message, I see a lot of 1s, and it is 1 because it's got 1, 2, 3 bonds, needs 4. The carbonyl again, this is called carbonyl, carbon. Good, and a bunch of zeros, that's 0. This one here. Okay, a bunch of 1s, we got it because we have 1, 2 bonds, 3 bonds. This one here, that arrow should be pointing a little further in. It's right there. Which one's that one? 0. Good. Got 1, 2, 3, 4 bonds. And now they're the wedged. Awesome. I'm seeing a lot of 3s. That one there with this is an alcohol. The carbon with the alcohol is got how many hydrogens? Just 1. Got the 1, 2. Good. Now you can read the bond line structures. You're a member of the Secret Organic Chem Society, so you got to learn the handshake now. Like Homer and I don't know who that dude is. Okay. One more quick review thing, and then we'll get into the new stuff. The bond line structures in 3D. That was in all 3 lab sections. I did the bond line structures in 3D. I introed that, like I talked about the different shapes: linear, trigonal planar, tetrahedral, trigonal bipyramid, and octahedral. Let me just review that really quick. So if I'm looking at this guy, this is from the animation I'm going to have you go through if you haven't already. And I have my black atom of this trigonal planar structure. The black atom is to the left, and I'm going to add on my red and blue. How would I draw those in here? I draw them in. Oh, this is a quiz you're going to take next week. I would draw the red in plane there, and the blue down here. Red and blue. And now this one, you could see, this one doesn't look exactly in plane, but it should be. But this one, see how I tilted it? So the blue is coming at you and the red is going away. So how do I draw that one? Actually, let's see if I can do this. So for this one, I'm going to have a wedge and a dash. Is the blue going to be wedged or dashed? You can type it into the chat.
Wedge.
Yep. Oh. Yeah, the blue is wedged at you, red is dashed back. Okay, for now this one, we have the blue coming at you. So how would I draw the red on this one? Would I draw the red wedged or dashed for this next one? The red is going to be dashed, yes. Red's dashed back, blue's wedged at us. Good. And now for the next one, where is my blue going to be on this next one? Wedged or dashed? Yep, blue is wedged, red's dashed. Good job. All right, now for a tetrahedron. So for the tetrahedron, I'm going to consider this black and yellow on the left. I'm going to put black and yellow in the plane of the page. So what is my blue? Is the blue wedged or dashed? I see a lot of wedged up there, and that is right. Blue is wedged, red is dashed. I had to put the yellow in a background of black, which is kind of confusing, but it's the yellow just doesn't really show up well on a white screen. Okay, next up, I'm going to put my blue and my black in the plane of the screen, and now is my red wedged or dashed? Red wedged or dashed? Yeah, the red is wedged. Good job, red wedged, yellow dashed. Okay, now I've got like a mountain shape here, where my yellow and my blue are in the plane of the screen. Is my red this time wedged or dashed? Nice, seeing a lot of good answers here. Red's dashed, black is wedged. Then for the final one here, I've got blue and yellow in the plane of the screen. Is my red wedged or dashed? Yep, red is wedged. Red wedged. Yes. Picking it up quick, I like it. Now for trigonal bipyramid, which we won't see all that much, we will use it for these sigma and pi bonding diagrams, the shape, but not a molecule with it, but we'll consider like these axial ones as p orbitals. But that's why I still include it. But let's see if we can do this one. Okay, so I've got the central atom A, and then I've got a black on top and a blue on the bottom, and they are in the plane of the screen. So my yellow, is it going to be in the plane of the screen? Or is my yellow going to be? Is it going to be wedge, dash, or line? Yeah, and so I'll draw the yellow as a line, and then the red will be wedged. So here we go. Let's see it. Boom. Yep. Yellow's in the plane of the screen, a line. Red is wedged, purple's dashed. Okay, now what about, I've got my blue and my black. The red one, what should I do for this red one on the second one? Should it be a wedge, dash, or a line? Good, in the plane, a line, and then the yellow is wedged, purple's dash. Good. Okay, now this third one, the purple, what should it be on the structure? Wedge, dash, or line? Good. See a lot of dashes quick there. Dashed, wedge, yellow, in plane. All right, and then the last one, the pink one here, wedge, dash, or line. Nice. Oh, I said pink. I guess it's purple. The light makes it look lighter. But yeah, line. Good, and the yellow's wedged out. Awesome. Last one, octahedrons. So an octahedrons, we won't really look at molecules much with an octahedral structure, but we can use them during the sigma and pi bonding diagrams for alkynes, for triple bonds. So kind of the idea of it. So, okay, so let's go with this white one. What do you think this white one's gonna need to be? Wedge, dash, or line? Yeah, the white one will be dashed back. The white's dashed back. And I had to put it in a brown background just so you can see that it's white. And then the red's dashed back and the blue and purple are coming out at you. Okay, what about this blue one in the middle? Where's that going? Which wedge or dash? Dash back, yeah. And the white's coming out at you. Awesome. And then finally, this purple one. How should I do the purple? Oh, wait, no, the purple's already dry, kind of dry. Let's go the black one here. Which one's that one going to be for the right one? Wedge, wedge, wedge. The white's wedged, yellow and blue are dashed. Purple and red are in the plane. Awesome. So now let's go back to our chapter outcomes, see where we're at. So we've mainly been just working through the first outcome of this chapter. It's a big one, huh? Took a while, this chapter outcome. We did the bond line structure stuff. We did the 3Ds. And in the Monday lab, I got to some of this counting secret hydrogens and formal charges. And then in the Tuesday, Thursday labs, I have 2 of them. In the 1045 lab, I didn't get to this. I was chatting more. but in the 2 p.m. lab on Thursday, I went Tuesday, I got to this. So I'll just kind of start here. So it'll be a little bit of a review for the Monday, Wednesday people and for the Tuesday, Thursday, 10:45 a.m. labs. But so this way the 2 p.m.ers no, it'll be a little bit of review for both 2 p.m. labs, Monday and Tuesday. All right, so, but let me see what time we got. Okay, we're looking good, good. Any questions before we start on that?
I had one question about the finding the errors thing.
Yes.
I submitted one, but it wouldn't let me. I was gonna, just to be more specific, take like a screenshot of it so that you could see exactly where it was, but it said it wasn't allowed from my perspective to send a screenshot of it. So I just like explained where it was. Is that okay?
Yeah, that's fine. And what you could do, a lot of students did this last semester. They would use like a Google Doc, and they would create a Google Doc, and then for the assignment, they would just turn that Google Doc into a PDF and upload it to the assignment area.
Oh, that's a better idea. Okay.
Yeah, if you want. You can, when you have a Google Doc, like this is a Google Doc here, I can go file, make a copy, is that what I do? Or not make a copy, I download as a PDF, boom, PDF or.
I think for me, I had to make a copy first because I couldn't edit your document, and then I was able to download it from to a PDF.
Oh, okay, cool.
So then I could write on the Google Doc, or I could write on the PDF.
Okay. Yeah, thanks for doing that too. And that helps to find those errors because as you're looking for them, you're more focused. Okay, so I'll get back with the counting secret hydrogens. I'm not going to go through the entire Google slide animation. I'll just kind of start it off because that you can do that on your own. But I'll give you the background. So when I was teaching, oh wait, before we start. So I'm trying to put notes like this. I decided I'll try to keep track of how long these Google slide animations take. I think it'll be a nice thing for students to see, like if there's a short one, like, oh, that'll only take 10 minutes, I'll knock it out. But if it's like, oh, it takes a half an hour, they're like, okay, I guess I'll start it soon, do half of it or whatever. So please keep track and then let me know. I don't know how, I haven't really set up a good way for you to let me know. You could just email me or just tell me in person or something, or I'll come up with something. So anyways, I was back in 2015, so that's 6 years ago now. I was teaching the students. Oh yeah, Discord board for that'd be good. Thanks. I was teaching bond-line structures, and Hannah, one of my students, she goes, oh, they're secret hydrogens. And I thought it was so funny. So that was kind of for the rest of the semester, it was like, how many secret hydrogens are here? We had fun with it. And they even made a t-shirt out of it. It was hype, it was fire. I'm just trying to use the young lingo here. So shh, it's a secret. It's a secret hydrogens. And that was, wait, 2016? I think it was, yeah, it was 15 during 12A, but then 2016 at the end of the year they made t-shirts, and 12B. All right, so I'm not sure our spirit animal Sky is too impressed. So it's easy to come up with I'll let you read the rest of the stuff on your own. It's easy to come up with the number of hydrogens when the carbon has no charge, not a positive charge or a negative charge, or when it has or lone pairs, like it doesn't have a lone pair of electron, doesn't have a radical single electron. It's easy to come up because you just go to four bonds. But when you have a carbon with a positive charge or a negative charge or a lone pair, it can be a little bit tricky. So that's what we're doing now. Let me go to the Jamboard. This is today's Jamboard. Yeah. Okay, cool. So I'll make up some examples. We'll work through it. Come on, iPad. iPad's warming up. Lecture jam? Oh, no, it is there, huh? Cool. Okay. So I'll just start making up some examples. So let's go boop, boop, boop. This molecule is ridiculously high in energy. I don't think it can exist on Earth, but it'll have things that we can try to figure out the number of hydrogen atoms. Okay, so let's see. The easy ones are the ones oh, you know what? I should actually start off by reviewing formal charge calculations. My bad. Let me do this. I'll add a new panel. Let's switch that. Oh wait, I'm still sharing my screen, correct? Yeah, I think so, right? Yeah, it says stop sharing, share. Yep, good. Thank you. Okay, so before I do this, I forgot I need to teach you about formal charge. Hopefully you've already done it, but this is just the way I do it. So formal charge. And I've already done this for 2 of the sections, so it's a review for the other ones, but it's not a big deal. Okay, so formal charge, I like to do it like this. You say group, whatever group you're in as an atom. So formal charge is for individual atoms. So whatever group you're in, like if you're carbon, you're in group 4 of the periodic table. So group minus the number of bonds, however many bonds you have, minus your number of electrons. All right, so group, for example, the main groups you need to know is just hydrogen is in group 1. And then if you skip over to boron, carbon, nitrogen, oxygen, fluorine, those are the main ones. Boron's in group 3, and then it's just easy to count across. Carbon's 4, 5, 6, 7, and then neon would be 8, but we don't really use neon much, but it, see the pattern there. And things below, like below boron, you have aluminum, that's also 3. And below carbon, you have, so that's also 4, pattern. Okay, so once you have the group, then you could calculate the formal charge. So let's look at an example molecule. Let me go boop, boop, boop. Let's calculate some of the formal charges here. So first off, this carbon right here, how many hydrogens does it have? 3. Good, has 3 hydrogens, yep. So this carbon has 3 hydrogens. What about this carbon, how many hydrogens? 2. 2, good job, okay. So let's calculate some formal charges for it. So this first one is a formal charge of, it's in group what? What group is that carbon in? You could type it into the chat too.
4.
Yep, it's carbon, group 4. Nice. Group 4 minus, how many bonds does it have? 4. Yeah, because if I add on the 3 hydrogens we talked about, that would mean it has 1, 2, 3, 4 bonds, right? So minus 4 bonds. And then how many electrons does it have? How many lone electrons, like lone pairs or radical electrons?
None.
Yeah, I don't see any. There'd have to be some dots by it, right? So minus 0 electrons. So what is its formal charge?
0.
0. So formal charge is 0. If if it's 0, you don't show it on structure. You just leave it blank. You don't show it on there because it's it would be like too many little zeros all over your molecule. Okay, so now let's move over to the next panel to do some more atoms on this molecule. Oh, actually, I want to add a panel. Okay, I'll draw it up again. So we figured out that first carbon. It's got a formal charge of 0. And actually, while we're at it, let's do with one of the hydrogens. So this one had 3 hydrogens, we said, right? This one had 2 hydrogens. So what's the formal charge of this hydrogen? What group is it in?
Actually, I had a question. It's kind of related to this, but for the quiz, I was practicing it yesterday. Does it matter how we do the expanded molecular structure? Does it need like what you're doing now with the branches of hydrogens, or can we write 3H? Does it matter the order at all, or how we represent that?
I'll make it real. Yeah, I'll make it real specific in each kind of question what I want, like whether I want it to be condensed CH3 or like with the bonds shown in, or with the bonds shown in wedge dash. So I'll make it really clear when I want that. And then for the quiz though, like from the Google slide animation, the answer key, that's what you want, that form.
You want it exactly
what I mean?
like that?
So yeah, so which Google slide animation were you referring to?
For the quiz for today. Because like I
Oh
think
yeah, today's quiz.
Yeah, so
Yeah.
one of them has like H3C instead of CH3 on the expanded molecular structure.
Oh,
that's
either
just-
way is fine. Either
Okay.
way is fine. Yeah. Yeah, good question.
Thank you.
Okay, so what group is hydrogen in? Do you remember?
1.
Group 1, huh? Yeah, there we go. Group 1. There we go. Copy that. Group 1. Group 1 minus how many bonds does it have currently?
1.
Sorry, my internet is slow. There it is. Okay, group 1 bond, huh? We see that 1 bond there. Minus 1. How many lone pairs of electrons does it have?
0.
0 electrons. Yep. So this guy's formal charge is?
0.
You could type it in the chat if you want. Yeah, 0. So it's don't draw it. Don't write it out on the structure. All right, and then you could hopefully tell that all the other hydrogens are 0, right? Because they all have just 1 bond, no lone electrons. Okay, but let's move on to a different one. Let's do this carbon right here. What group is it? You can type it in the chat. Group 4, yep. Okay, and how many bonds does it have? I'm seeing a lot of 4s. Yeah, 4 bonds. It has a bond to a hydrogen, bond to a hydrogen, bond to a carbon, a bond to a carbon. 4 bonds. How many lone electrons? Lone pairs. Yeah, 0 dots around it, right? So its formal charge is 0. Good. Okay. Let's move on again. What about this one? This is called the carbonyl carbon. That's in group what? Carbon's in group. Type it into the chat. Carbon's group in the chat. 4, yes. How many bonds does it have? It has 4 bonds too. 1, 2, 3, 4. And you notice how I'm like writing out, instead of just putting 4 minus 4, I'm putting group 4 minus 4 bonds. It's good to do this initially. It helps you memorize the formula. How many lone electrons? 0 electrons. So the formal charge for this one, 0 again. Good. All right, so this has been boring. They've all been 0, but it'll get better. Let's go. Let's add another panel on here. Okay, so let's do these oxygens. Oh. I just kept writing. Okay, so what about this oxygen at the top? What group is it in? Yeah, if you look at the periodic table, it's group 6. Oxygen's group 6. Boron's 3, carbon's 4, nitrogen's 5, oxygen's 6. Okay, so group 6 minus how many bonds does it have? Minus 2 bonds. Because it's got a double bond to the carbon below, huh? And then how many electrons? Yes, good. 4 electrons. It's you count each electron individually. You don't count it as like, oh, that electron has. I mean, this guy. You don't say this oxygen has 2 lone pairs of electrons. No, you say a full 4 electrons. That's how my formula is used. So what is my charge on this? 4 minus 2 minus 6, 0. Yeah. Still no formal charges yet. Maybe we'll get lucky on this one. Okay, the formal charge of this final atom, this final oxygen, it's in group what? Oxygen's group 6 minus how many bonds? 1 bond. It's got the 1 bond right there to the carbon. Minus how many electrons? It's got 6 electrons, huh? 1, 2, 3, 4, 5, 6. So 6 electrons. So what's the formal charge for this one? Six minus 1 minus 6, it's -1. So we got a formal charge finally. And what I want you to do is whenever you have a formal charge, put that formal charge right by the atom and circle it. I like to have it circled. It makes it stand out for me. So I'm not of this so much. You might have learned how to do for Lewis structures this way, where you put just like a minus around the whole molecules. I like to be more specific, put the minus right by the atom that has it. So.
Is that so putting the circle in the minus, so that would be the formal charge, because like the delta minus would be like a partial charge, right?
That's right.
Okay.
Yeah, we'll do that. We'll talk about that. Yeah, and that in Lewis structures, I go into that. Yeah, put the okay, good. Good. All right, we're getting good at that. Now, I'm gonna do, before I do the secret hydrogen thing, I'm gonna do some trickier ones here. Let's go here, let's go there. Okay. Let's say I have Let's calculate the formal charges for these ones. So what do you think the formal charge is for this carbon? So what group is it in? Yes, group 4. So I can go back and snag our little cheat sheet here for this. Group, okay, how bonds does it have? Good, chat is going off. 3 bonds. How many lone electrons does it have? 2 electrons, yep. So what is the formal charge of this one? Four minus 3 minus 2, it's -1, got a formal charge. So this guy, we want to put a little negative right by it. My circle looked now. Yeah, these are called, when you have a carbon with a negative charge, they're called carb anions. Carbanions. We'll talk about those later. Cool. Okay, now this one, let's look at this carbon. What's its formal charge? So it's in group what? Group 4. We'll have that memorized by the end of today's lecture, hopefully. Minus how many bonds? Yep, -3 bonds. Minus how many lone electrons? -0 electrons. So does it have a formal charge? Yes, +1, good. So we'll put a plus sign right by that. These guys are called carbocations. We'll see these a lot. Carbocations. Okay. Now we did a carbon with a lone pair. We did a carbon with no lone pairs, but only 3 bonds. Now we got this one down here. We got 3 bonds and a single, this is called a carbon radical. The radical dude. Okay, so we got a carbon radical. What's its formal charge? Radical refers to an atom that has an unpaired electron. Okay, so formal charge. We'll talk a lot about those two later. So group what? Group 4 minus how many bonds? -3 bonds. Minus how many lone electrons? -1 electron. So what's our charge? 0. No formal charge for this carbon radical. It's neutral. It's still very reactive though, because we'll talk later about octets. It doesn't have an octet. It only has 2, 4, 6, 7. But yeah, you're getting it. Okay, so now we're going to kind of do this sort of calculation backwards.
So we left off, we were doing the calculating formal charges for carbons with lone pairs or missing bonds or lone electrons, radicals. Now we're going to do the opposite, the backwards version of that. We're going to look at a bond line structure and then figure out how many hydrogens it needs to support its formal charge. So for instance, I'll start with an easier one. Here, let me just say, easy. What did I say easy? Okay. Counting secret hydrogens. Are my AirPods on? Let me see. Oh, they're not on right now. It's okay.
Okay. So the way we're going to do this is that I typed up there, you're going to count. You're going to figure out how many secret hydrogens something has by guessing how many it has and then checking the formal charge. And for neutral carbon atoms that have no lone electrons, it's easy. It's just 4 bonds. That's the kind of the trick we started with. And also, I haven't heard anything. Can everybody hear me so far?
Yeah.
Okay, thank you. All right, let's start, like I said, with an easy one. Let's do my iPad over here.
Let's start with this this terminal carbon here. So what's your guess? Guess how many hydrogens? So what's our guess? How many hydrogens do you think it has?
3.
Yeah. My AirPods shut off for some reason. Oh,
Over. Okay. Turn off the Bluetooth on the phone. Okay, so we're guessing that it has 3 hydrogens. Okay, if that is the case, let's now check it with the formal charge. So that carbon is in group what?
4.
4. Good. And how many bonds does it have if it has 3 hydrogens?
4.
4 bonds. And how many lone electrons? 0. Good. So what's the formal charge supposed to be then if it has 3 hydrogens?
0.
0 hydrogens, yeah. I mean, 0 formal charge. Weird, right? Twice different to you guys. Oh, switch to transparency. Your internet is unstable. Sorry. Okay, so does that check out with our structure? Does our structure show that it has 0 charge before we added all those hydrogen stuff? That checks, right? Because we didn't have a plus or a minus by this. So checks out. It has 3 hydrogens. And that's kind of this using the formal charge to check your answer. That's the way you can always get the right answer on these. But when I showed you the shorthand initially, if it's got no charge or lone electrons, you could just say 4 bonds. But now let's do this one here. Oh. So this one's the more tricky one. So let's just guess 0 hydrogens first. We'll call this our first guess. So if that carbon has 0 hydrogens, then let's check the formal charge. Formal charge would be group what? 4 minus how many bonds? It has 0 hydrogens. It would just, if it has 0 hydrogens, it only has the 2 bonds that are shown to the carbons. So 2 bonds. And then how many lone electrons? I see 1 lone electron there, minus 1 electron. That would make us have a formal charge of what? 4 minus 2 minus 1 plus 1. And that doesn't match our structure because our structure doesn't show, I don't see a plus 1 by it. It's got nothing by it. So it's saying that it has 0 formal charge. So this means that the carbon does not have zero hydrogens. So that's not a correct guess. So let's try a second guess. So let's say for our second guess, oh, maybe there's 1 hydrogen. And then we'll check with our formal charge. So we'll say formal charge equals, what group are we in? 4 minus how many bonds? So if it has 2 bonds to other carbons, and now we're saying, oh, there's also a hydrogen here, it would have 3 bonds now. If for our guess of 1 hydrogen, there'd be 3 bonds, minus how many electrons? Minus 1 electron. And what formal charge does that give us? 0. So that is correct. So that means that, oh, good, this carbon has 1 hydrogen. Because our formal charge calculation says 0 charge. All right, so now let me try this. Can I have to just redraw this molecule on the next panel because it's got too much going on it right now. Okay. Okay. What about this one? What's our first guess? How many hydrogens do you think it has? Someone give me a guess of how many hydrogens they think that has. Okay, I see a guess of 0. I see a guess of 1. I see 2 guesses of 1. Let's try the 1 first, since that was 2 guesses. Guess 1. So then we'll check it with the formal charge. So the formal charge, if it has 1 hydrogen, would be that it's in group 4 minus how many bonds would it have if it has 1 hydrogen? It would have 4 bonds. And how many lone electrons would it have? How many lone electrons does it have? 0 electrons. So what would its formal charge be if it had only 1 hydrogen? 0 formal charge. Is that correct? Is that what we see for the molecule? No, we don't see that. Wrong. Because it's got a plus charge, formal charge. So it can't have that 1 hydrogen. What's the second guess?
So for the formal charges, if it had a formal charge of like +2, would you write +2 and then put a circle around it? Plus
Yes.
is +1. Okay.
Yep. Yeah. Oh, the only time you really see that, well, the first thing I think of is like something like calcium. But on a carbon, I don't think you'll ever see a carbon +2 or oxygen +2 or nitrogen +2. So organic atoms and organic molecules, I don't know of any +2 or any minus. Do I? Carbide? It's not the single carbon is -2, right? Yeah, no, that's only, yeah, I'm thinking carbide like this. But that's each carbon still just -1. Yeah, so because have +2 or -2 on a carbon, oxygen, nitrogen, it's really high in energy. Good question. All right, so we're going 0 hydrogens. I see some guesses to check that one now. So the check is, if it has 0 hydrogens, does it give it a +1 charge? If it does, then that's correct. So the formal charge would be group 4 minus how many bonds do we see on this if we have 0 hydrogens? 3 bonds minus how many electrons? 0 electrons. Does that give us a +1 charge? Yes, correct. That carbon has this 0 hydrogens. And we're going through this whole long process because it's really good to be good at calculating formal charges. But as we go through the year, you're not going to be doing these calculations. You'll just like know, you'll just remember, oh, that's a carbocation. It just kind of becomes second nature, but it is really good to know, like, we start out and do it the right way. Okay, now what about this one? What's our first guess? Two hydrogens? Okay, let's try it. Two hydrogens. So then we'll check that with our formal charge. It's carbon, it's group 4. And if it has two hydrogens, how many bonds total would it have? 4 bonds. Because it would have the 2 that are shown and then 2 hydrogens. That'd be 1, 2, 3, 4 bonds shown. And how many lone electrons does it have? 2 electrons. So what's the formal charge if it has 2 hydrogens? -2. Uh-oh, that's wrong. That's not good because I only see a -1 charge here, not a -2 charge. So first guess was wrong. That's okay. What's the next guess? How many hydrogens? I see a 1 hydrogen guess. Okay, let's try it. The formal charge would then be group 4 minus, if I have 1 hydrogen there, how many bonds would that give it? That would give it 3 bonds. And how many lone electrons? 2 electrons, good. And the charge we would get -1, it's correct. So this carbon here has 1 hydrogen to give it that -1 formal charge. Pretty cool, right?
Question.
Okay. What was that?
I have a quick question.
Uh-huh.
Would it work to set the formal charge to 0 and then solve for number of bonds?
Not for that one. For that one, it would work if you went, let me go to the next slide. I like your question. Did you ask a similar question in lab yesterday?
No.
Someone else did. They worked out a formula for it, which this is another way to do it. But I think the guess and check might be a little faster. Yeah. So what you're saying is, okay, let's go. Group 4 minus X bonds minus 2 electrons equals -1, and then you just solve for X.
Yeah.
Yeah, that definitely works. So when I do that, it's like 4 minus X minus 2 equals -1. So X equals, well, it's a 2 minus X equals -1, minus X equals -3, X equals 3. So now I have 3 bonds, which means I have to need 2 to carbon, plus I need 1 to hydrogen. So I have 1 hydrogen. So yeah, that is another way to do it. Good mathematical thinking, I like it. Okay, and now we're good with the secret hydrogens. Let's see if you want to get a glance at the, this is the Google slide animation, takes you through the same stuff. And I have the quiz that we will do. I think this quiz is Monday, Tuesday next week. Let's look at the schedule. Is that the schedule? No. I got 2 of those on my note. Here it is. Yeah. Bond line structures in 3D and counting secret hydrogens. Got 2 quizzes. I'm gonna put a space between those so you can tell there's 2. So 2 different quizzes on Monday, Tuesday. Let's look at the counting So here's the quiz for counting secret hydrogens. Here's the animated key. Let's play through it and see if we can do it real quick. So I'll get the chat up on my end. Let's see what this looks like. So which one am I doing first? Okay, I'm doing that one first. So this guy right here, it has no charge. It has one hydrogen. Because if you have one hydrogen there, you can do the formal charge kind of quick in your head. It's because it's group 4 minus 2 bonds and 2 electrons. 4 minus 4, 0. Yeah. And then this one here, this one has no charge. It's an easy one. How many hydrogens for this guy? Just one hydrogen, huh? Oh wait, I'm going the other way. I don't know where my key, I didn't know which way my key was going. My key's going counterclockwise. I thought I was going clockwise. So that one has one hydrogen as well, though, because it has 3 bonds in the 4th. And now this one's a tricky one, the one with the anion here. Does anybody know how many hydrogens it has? 1 hydrogen, because it has to have 1, 2, 3 bonds minus 2 electrons. That's 4 minus 5. So this will be your quiz. You'll get this like so, all blank, and then you fill it in. Exact same molecule, exact same atoms asked for. So you should be able to do well on it. Just got to practice it a little bit. This quiz will be maybe a little trickier than the other ones. Not that much, but now we're done with outcome 1 of OChem, which was a really long one. I used to teach bond line structures, I think in like chapter 2 or 3. But then I was like, no, I got to get that right away so you can, so I can right away start using them, because they're so much more convenient to draw instead of having to write out like CH3, CH2, C, all the atoms. So, okay, we're pretty good at this bond line structures. Let's move on to outcome 2, define an organic molecule. So I've been saying this in lab, and you can look it up online. An organic molecule is just a molecule with a carbon based. And interestingly enough, our bodies are mostly made of water. Oh, and then I got a question on the chat about how many times we get a quiz. I'm doing a lot of these little short quizzes in the beginning, and they'll be less throughout the semester. The beginning of the semester, I have more because I have a few. I'm not a big memorize things guy, but I do have some things I know that if you just memorize these 5 things, it makes everything else easier. So I will have a few quizzes you'll see in the beginning like we do now. But I'm hoping you feel like these quizzes, these ones, which you have the key already in front of you, that you'll feel a little bit like, oh yeah, they're kind of easy points because you already have the quiz and the key. Yeah. So
I meant more of like how many minutes roughly are we given to take them?
Oh, I'm sorry. Yeah. Time. Read it slow enough. Yeah, so the way I work it out in lab, I try to give everybody plenty of time. I don't want it to feel like you have to rush through it. So what I do is I've already got my outline and lab set up. I say, okay, everybody come on into lab, show me your green pass, and then come on in and I'll give you the quiz right away. You'll start working on that. And then when you're done, bring it up front to me, hand it in, and then bring up also your pre-lab. And I'll be checking off your pre-lab. And then after you're done with that, you go back to your counter and I have a practice, like a problem up, I call it not an exit question, but an entrance question. And you can work on that. So the people who are quick with the quiz, they turned it in quickly. They come up and get the pre-lab, go back and work on their entrance question. The people who are, double checking and taking their time on it, they'll come up a little later to get their pre-lab checked, so it all kind of works out. So it depends on the quiz. I just sort of go by feel. Once I see everybody's, usually I'll just wait till everybody's done. And if you're taking a little longer and you need a little more time, I usually just like say, oh yeah, want to just have a little more time, we can put you back in the instrument room and then it's quiet back there and you can finish up. But for these ones, they should be relatively quick for you. So I don't want you to feel like it's a time pressure, but I think usually people finish them pretty quick, like the bond line structure quiz. It's pretty short. Yeah. So does that help? Cool. Okay, so yeah, these what I think of them as like skills-based quizzes or an obvious quizzes. I call it obvious because you have the questions in that key beforehand. I don't want you to think of them as this high pressure thing. I want you to see it as like, oh yeah, I'm gonna get all the points on this, and it's gonna help my grade. That's what I want it to be. Okay. All right. So where was I? Oh yeah, back to the outline. So organic molecules. Okay, so our bodies are mostly made of water, but if you dehydrate us and you take away all our water, we make human jerkies out of us, or like beef jerky, then we're mostly carbon atoms actually, because our fats, our proteins, our carbohydrates are carbon-based organic molecules. So organic refers to molecules of life of plants and animals besides water. And originally, though, that's the current definition of organic molecules. But originally, back in the day, scientists thought of organic molecules and organic reactions as things that only take place in bodies of animals or plants, or inside of plants or animals. So they thought like there's certain molecules and reactions that can only take place inside of a body or in a plant, and that's like magic, you know. But then it was proven false because this guy Frederick Wooler, he was trying to make a molecule that he considered like inorganic, not inside the body. And when he was trying to make one particular molecule, he accidentally made another. He made urea, which is a molecule made in the body. And he's like, wait, I just made urea outside of the body. Oh, then there's nothing magical about reactions in the body. They can happen outside the body, which was huge because now you're like, oh, I can make, you know, insulin and things like that. Well, I guess we don't really make insulin outside the body. We use another body to do it, or whatever, but other molecules. And Wooler's discovery was an accident. And there's a lot of awesome accidental discoveries in science. So he was trying to make one molecule and he made a different one and discovered the whole idea that this old theory of the magical reactions in the body isn't true. Okay, and then some of my outcomes you'll see, I just kind of go through them quickly. You can look them up more, and but then the ones that are, I feel like most important that you definitely will have exams, I'll make it obvious, like this one here. So functional groups. So functional groups, they're something that's very helpful. They help you learn reactions about molecules, that kind of classify molecules and learn their reactions easier. So let me put this in the Jamboard. I'll tell you what I mean. Show you what I mean. So this is from the chapter outcomes.
Would you recommend that we memorize these, like do kind of a flashcard thing with them?
Yeah, we will. Yeah, this is one of the things where I said I don't do a lot of memorization, but this is one that we will memorize. Yeah, I found that memorizing these really helps, because then when I'm talking about, oh, see the alcohol, you'll just know right away it's an alcohol. But if I say alcohol and then you have to go look up what an alcohol looks like and then come back, it's kind of just cumbersome. It's not good. It's like when you're learning as a kid to read. If you don't know the sound of the letter A, it's not going to be as fun to read Harry Potter. You got to get some basics. So yeah, you will memorize these, and I will have a quiz, and I do have a lot to help you memorize it actually. But functional groups, what are they? Why do we have these? So there are millions and millions and millions of organic molecules, and if we needed to learn like how each one of them reacted, that means we'd have to learn the reactivity of millions and millions and millions. And it's too much. So what we do is we take these millions and millions of molecules and we put them into categories, and then we say like, okay, these type of organic molecules are all alkane or functional group, and they'll have a certain type of reactivity, a certain type of physical property, and then so that'll be good. So alkanes, and then we'll have other molecules with double bonds in them, and we'll say, oh, those are the alkenes, and they have particular reactivity. So instead of having to learn the reactivity of a million individual alkenes, you just kind of learn that all those alkenes kind of react the same. So yeah, and then alkynes, benzene rings, alcohols, amines, blah, blah, blah. So let me go through, I'll show you back on our outcomes. I have a lot of things to help you out with this. Oh, and besides these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 functional groups. I'll also have you remember, I'll have you memorize alkanes. These are alkanes. The 10 alkanes, first 10 alkanes meaning like an alkane with just one carbon, then an alkane with 2 carbons, 3 carbons. And it's not too bad. I'll help you with it. So I've got 3 functional, I have 3 GSAs to help you out with it. Like the first one's just introducing all the functional groups. And then this one is like to help you memorize them. My like strategy to memorize stuff. So you don't necessarily have to make flashcards. You can use this stuff. And then this is the actual quiz you'll get for the functional group quiz. It'll be the exact same quiz, and this is the quiz and the key. But let's look at a little bit of these, the functional group GSA. I won't go through the whole thing, so I'll let you do it, but I'll kind of get the feel for it. I'm letting it load. So as always, present. And then when you go through this, please time it and let me know. All right, so functional groups. So this should be fun, right? Yay, fun period. I like how the band fun, they have the dot, so they're fun period. So functional groups are used to segregate molecules into their physical properties and reactivities. Segregation is fun. I mean, for molecules, not for people. But we're made of molecules. Okay, let's put the people. Let's put all the people together, but segregate them, separate the molecules. Okay, wait. Let's not blow people up. Okay, I'll let you read the jokes later. So, got some memes in here to try to make it fun. I'll go through it quickly. I'll get to the things. I'll let you read it. So butane's a bastard gas. Remember that from lab? So that's the 4-carbon alkane. And then if you have double bonds, now you're not an alkane, you're an alkene. So this one does have single bonds like an alkane, but once you have some alkenes, then you can say the molecule has alkenes. Okay, so here are the first 10 alkanes to memorize. It's going slow for some reason. So the 1-carbon alkane is methane. That's the one produced by farting and burping cows. And it's a greenhouse gas. It's not too good for us right now because it's 20 times stronger than carbon dioxide as a greenhouse gas. So right now we have more carbon dioxide in the atmosphere, which is warming up the planet a bit. And methane is also doing that, but worse so because it's 20 times stronger as a greenhouse gas than carbon dioxide. So it's actually better to take methane and burn it in oxygen to oxidize it to carbon dioxide. Then it's a 20th as bad. So there's some farms, it's pretty cool. The cows, they fart out a lot of methane and burp as they're eating and doing their biological processes. And the farms will actually collect that gas and then use it to power their cheese making machines. So they'll make it 20 times better by using the methane to make the cheese and also to make carbon dioxide come out instead of the methane. That's interesting, huh? So, oops, wasn't me. All right, so ethane is the 2-carbon alkane, and it looks like that. Or the bond line structures there. 1, 2 carbons, right? And then propane's next. That's like our barbecue tanks. You have a propane gas barbecue tank like the Blue Rhino. And then butane, my daddy said butane's a bastard gas. You got that one there. And then butane's a bastard gas. And then 5 carbons, pentane, 1, 2, 3, 4, 5. You can draw it in the bond line structure. You can see as you get longer chains how it's so much more convenient to just draw 1, 2, 3, 4 lines like that to draw out the molecule versus having to write CH3, CH2, 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 CH. So these first 5, to help me memorize it when I was a college student like you, I would eat peanut butter and jelly sandwiches like all day, every day. I had like a loaf of bread and peanut butter and jelly at school, and then one at my work. and at home, of course. So I'd be at school all day, and I'd just go into. I worked at the time in the chemistry computer lab at school. So I would have there was an office there I could store stuff. So I'd go and make like a peanut butter and jelly sandwich in between class. And then when I was at work, the same thing, just make peanut butter and jelly sandwiches. So helped me remember this. What helped me remember this is I thought of it as all I eat is me, PB, and J. So the J doesn't apply, but all I eat is me, PB. So me, methane, ethane, me, propane, butane, pentane. Well, pentane actually? No, it's just the first four. Sorry. So me, PB helps me with the first four because the first four aren't obvious. Like methane doesn't sound like one. Ethane doesn't sound like two. Propane, butane. But pentane, what does pentane sound like? Does it kind of remind you of 5 carbons? Anyone? Does pentane sound like 5? It does. Pentane sounds like 5 because it's like a pentagon. The shape pentagon is 5. All right, and then it gets me, PB. I'm almost done for the day. I didn't realize it was already 12:45. I'll finish up shortly here. There's the Pentagon in Washington, D.C. Pretty sweet looking building from the sky. All right. And then let's just get to 10. We'll stop. So 6, I remember, is hexane. It reminds me of, it's a 6 carbon. It reminds me of a witch, like a witch puts a hex on you, like this witch from Wizard of Oz. And a hex reminds me of a witch. And then the number, what's the evil number? What do people say, like in old heavy metal albums and stuff? What's the sign of the beast, the evil number? 666, right? And it has a 6 in it, so hex 6, that's how tie it together. But there's some interesting discussion about, is 666 the evil number, and why is it called the devil's number? And this discussion is pretty cool, how it says it's kind of code for the ruler of Rome. So they were putting in the Bible, like, oh, I think it's not Caesar, but it's another one. It was like code, like political code in the Bible. Is interesting. So yeah, so 666. And I used to be afraid of this witch. Wizard of Oz was on every year around Thanksgiving, and her flying monkeys scared me. Yeah, those flying monkeys. Now it's so cheesy, but back then it scared me. All right, so 7, heptane. So heptane has 7 carbons. So we got 1, 2, 3, 4, 5, 6, 7. 7's not that easy to remember. Hep doesn't sound like 7 to me. It does to me now because I've taught Chem forever, but it doesn't seem like it's common. But it makes me think of that movie 7, the 7 Deadly Sins. So hexane 6, 7. I don't know. 7's just, I don't know if you can think of a better way to remember 7. 7 sort of I remembered it initially as like it's the odd one, but octane was easy because octane just sounds like 8, right? Like an octopus has 8 arms. Actually, they kind of, some people say they have 2 legs and 6 arms, which is kind of cool. It adds up to 8. And the octopus or the octopi are pretty awesome. They can change the texture of their skin to match like the sand around them. And they can fit into tiny places. They could change the texture and color of their skin to camouflage. And they can spray ink. And they can evade predators using tools. So they can learn how to use tools. They did this cool study where they had one octopus in a tank, and they taught it something, and then they put another octopus in a tank next door, and it learned by watching. I'm like, oh, that's pretty cool. And it helps us for octane. And then 9 is nonane. And that was not too bad because it sounds like 9. It has the letter N, nonane. So sounds kind of like 9. I've never seen this 9. And it's decane 10 because it sounds like me in the decade, the 90s, decades ago. So it sounds like 10 deca. So not too bad, right? And then I got some more stuff. So I'll pause there. We'll pick next lecture at, yeah, we'll do some more of the, we'll practice a little bit with this, but really it's just going to be on you to go through this. And as you go through it, you'll boom, boom, boom. I got a lot of stuff to help you out with it. You'll get them down. Oh, and then this is kind of fun. It's purposeful game. My friend shared this with me. I'll show you real quick before we go. It's just a little video game where you have to like, click on the correct functional group when they name it, and you get timed, and you see if you can do it fast enough. Here, I'll see what time I get. So I'll go play aromatics. That's the aromatics. Acid halide right there. Alkene right there. Amine. Amine. Ether there. Ester there. Alkyl halide here. Alkane there. Alcohol. Where's alcohol? Alcohol. Amide. Ketone. Aldehyde. I should be just looking for the ones that are thiol. Boom. Carboxylic acid. Alkyne. Dude, I got 100% right. 46.9 seconds. See if you can beat my score. So this game, it has a little bit more functional groups than we have to memorize. Like, I don't think I have the acid chloride down for you to memorize yet. But if you wanted to play with it, you can keep trying and beat your score. Okay.